Alright, so we have an absolute value inequality that we have to solve here. So just a reminder, when we're solving absolute value of something, absolute value of x is less than or equal to a, we can solve it as treating it as a compound inequality like this. Whatever's in the absolute value bars we put in the middle, and then a goes on the right and negative a goes on the left. And on the other hand, when we're solving absolute value of x is greater than or equal to a, we can split this into two separate inequalities. We go x is greater than or equal to a, or x is less than or equal to negative a. Notice on the second inequality we flip the inequality sign and we make the a negative. And this is true as long as a is a positive number. Alright, so looking at the inequality where we want to solve, notice that's a greater than inequality, so we're going to be utilizing this rule. So we're going to break it into two separate inequalities. The first inequality, all we do is drop the bars. All we do is drop the inequality bars. And then we write or. And on the second inequality, we do two modifications. We flip the inequality sign and we make the number negative. And so now I have to solve these two inequalities separate. So to solve this, the first thing I'll do is put parentheses or brackets around the inequality and multiply by the common denominator in order to remove the fractions. So 5 goes into 10 twice, so we'll have 2 times 3x minus 6. And then when I distribute the 10 and I multiply it by the 7 over 10, the 10's just cancel, so I'm left with 7. And then we'll distribute the 2. And then we can add 12 to both sides. And finally divide by 6. And then now I'm going to solve the other side. Once again, I'm going to multiply by the common denominator in order to remove the fractions. And again, we have 2 times 3x minus 6 less than or equal to negative 7. And distribute the 2 again. And then we're going to add 12. And let's see, negative 7 plus 12, that'd be positive 5. And divide by 6. At this time, the inequality is solved. But MyMathLab wants interval notation. Sometimes it's easier to get interval notation if we graph it first. So here's a number line. 5, 6 is the smaller number, so I'll put that on the left, and 19, 6 on the right. And we have x is greater than or equal to 19, 6, so I'll shade to the right with a bracket or a closed circle on the 19, 6. And then x is less than or equal to 5, 6. That means we shade to the left. And since there's an equal sign, we put a bracket or a closed circle on the 5, 6. So the interval notation is negative infinity to 5, 6 union 19, 6 to infinity. And so this is, the interval notation is what we want to enter into MyMathLab.